We are studying the second chapter, Numbers and Sequences. Today's topic is modular arithmetic. Let's go to the definition. Modular arithmetic is a system of arithmetic for integers where numbers wrap around a certain value. Example, days of the week. After 7 days, we start at the first. Okay. After 7 days, we do not say 8th day, 9th day, 10th day. No, we say the first day of the week. So after 7, the week starts again. Similarly, you will find many examples like the 12 months of the year. We'll say after the 12th month, December, we will not say 13th month, 14th month. We will again go back to the number 1, first month of the year. So this kind of arithmetic is called modular arithmetic. Next is congruence modulo. Two integers a and b are congruence modulo n if they differ by an integer multiple of n. So here we need, for congruence modulo, we need two integers and the difference of these two integers, that means a minus b should be a multiple of n. So we can write it also like this: a minus b is equal to kn. Kn means it is a multiple of n for some integer k. This is written as a congruence b modulo n. Here the number n is called the modulus. Okay. In other words, a congruence b modulo n means a minus b, that is a minus b is divisible by n. We can say that this is divisible by n, or we can even say a minus b is a multiple of n. Okay, we will do lot of sums on this. It will become very clear. Only thing you should remember is that whenever we say a congruence b modulo n, that means a minus b is a multiple of n. Okay. Now we will correlate this idea with Euclid's division lemma. We studied about Euclid's division lemma, the first exercise and all. You know that a is equal to bq plus r. Okay. That means what? A is the dividend, b is the divisor, q is the quotient, r is the remainder. Oh, is it not, in Euclid's division lemma? So we are going to write this lemma in this form. Okay. A congruence b mod n. So here we are not interested in the quotient, only the remainder. Okay. So here you can see that when a is divided by b, you get the remainder r. So you write it like this: a congruence r modulo b. What this means? That a is divided by b and it leaves the remainder r. This is r. Okay, this is b. Mod b means b is the divisor and a is the dividend. We'll do sums on this. It will become very clear. But interestingly, this formula we are able to correlate with division lemma. So it makes mathematics very easy. The division sums and all very easy. Easily we can get the remainder. Even if you divide very big numbers, you can write the remainder easily through this formula. Okay. There are two important theorems in this, theorem 5 and theorem 6. These concepts we will use in our problem sums. So just learn the theorems. Don't need to learn any proof and all in this. We will apply it in our problem sums. Very simple. Supposing there are two numbers like a congruence b mod m and c is congruence d mod m. Okay. So the mod m, that is the divisor of these two numbers, a and c, is the same, that is m. But when you divide a by m, you get remainder b. If you divide c by m, you get the remainder d. That is the meaning of this. Okay. Now if you have these kind of two numbers, then you can write a plus c congruence b plus d modulo m. Okay. Similarly, you can write a minus c congruence b minus d mod m. Multiplication also you can write a into c. A into c is congruence to b into d mod m. So this is a theorem, just have to remember it. And then the theorem 6 states A congruence B mod m, then for any integer c, if you multiply c on both sides, LHS and RHS, they will also be congruence. So A into C congruence B into C mod m, and A plus or minus C is congruence to B plus or minus C congruent modulo m. Okay, so these are theorems which you have to remember, because we are going to apply them in problem sums. Okay, let's go to the exercise. Exercise 2.3, question 1. Find the least positive value of x such that 71 congruence x mod 8. So what does this mean? This statement, 71 when divided by 8 leaves the remainder x. That is the meaning of this. This mod m mod 8 is the divisor. Okay, let us write down in the general form. 71 minus x is equal to 8n, where n is any integer. Okay, what does this mean? 71 minus x is a multiple of 8. Okay, it also means 71 minus x is divisible by 8. It's the same thing. Okay, is divisible by or is a multiple of 8. It is the same idea, but we will write this always, that 71 minus x is a multiple of 8. Okay, now take the rough paper and do the actual division. 71 divided by 8. You will get the quotient 8 and remainder 7. Okay, look at the remainder. Now what we are going to check, if this satisfies this equation or not. Put the x value is equal to 7 and do this. 71 minus 7, you get 64. And you can see that 64 is a multiple of 8. Is it not? 8 8s are 64. Therefore, x is equal to 7 is the least positive value of x. There are many more values, but this is the least positive value of x. Okay, next sum. 78 plus x congruence 3 mod 5. Let's write 78 plus x minus 3 is equal to 5n, where n is any integer. Simplify this. 78 minus 3 is 75 plus x is equal to 5n. That means 75 plus x is a multiple of 5. Write it down. Okay. So here we have to find the value of x such that 75 plus x is a multiple. Okay. We can take x is equal to 0, then 75 is a multiple of 5. But we cannot take x 0. Why? Because we need least positive value. Okay, positive value. So we cannot take x 0. Take x is equal to 1. 76 is not divisible by 5. But if you put 2, 3 also, it will not be divisible. But if you put x is equal to 5, you can see 75 plus 5 is 80, which is a multiple of 5. Okay. Multiple means is divisible by 5. 80 is divisible by 5. It's the same thing, but we will write it like this, which is a multiple of 5. 80 is a multiple of 5. So x is equal to 5 is the least positive value of x. Third sum, 89 congruence x plus 3 mod 4. So write down 89 minus x minus 3 is equal to 4n. 89 minus 3 is 86. 86 minus x is equal to 4n, where n is any integer. So 86 minus x is a multiple of 4. So you have written it. Now do the actual division. This in the rough paper, okay, not in the main sum. So if when you divide 86 by 4, you get the quotient 21, remainder 2. We are only interested in remainders in this congruence modulo. We are not bothered about the quotient. Okay. So remainder is 2. So let us put x is equal to 2. Check if this is correct or not. So if you put x is equal to 2, you get 84, and 84 is a multiple of 4. That means it is divisible by 4. 84 is divisible by 4. Therefore, we can say 84 is a multiple of 4. Therefore, x is equal to 2 is the least positive value of x. Next sum, 96 congruence x upon 7 mod 5. So here let's again write down 96 minus x upon 7 is equal to 5n. So 7 is the LCM. So 96 into 7 is 672 minus x is equal to 7 into 5, 35n. Okay, this is the general form. So you can say that 672 is minus x is a multiple of 35. Okay, now do the actual division. You will get the quotient 19, remainder 7. This in the rough paper only. Okay, now let us take the value of x as 7. See if this is correct or not. So if you put x is equal to 7, you get 672 minus 7, that is 665, which is a multiple of 35. Okay, if you divide 665 by 35, you will see that the remainder is 0. Okay, therefore x is equal to 7 is the least positive value of x. Question 5. 5x congruence 4 mod 6. 5x minus 4 is equal to 6n. Okay, so x is equal to 6n plus 4. This minus 4, I have brought it on this side, so it becomes plus 4. And then the 5 goes into the denominator. So x is equal to 6n plus 4 divided by 5. Okay, now let us try to find the value of x. Put n is equal to 1. 6 into 1 is 6. 6 plus 4 is 10. 10 upon 5 is 2. So you get the value of x as 2. Okay, so that means the least value of x is when n is equal to 1. If you put other values like this, you will get higher values of x only, but they are asking the least value of x. So when n is equal to 1, x is equal to 2 is the least positive value of x. Question 2. If x is congruent to 13 modulo 17, then 7x minus 3 is congruent to which number modulo 17? So they have given x is congruent to 13 modulo 17. Let's write it down. X congruence 13 modulo 17. So this is given. They are asking us to find 7x minus 3 is congruent to which number? Let that number be p, capital P. So 7x minus 3 congruence p modulo 17. So they are asking us to find p. Okay, let us start from here. They have given x is congruence 13 mod 17. That means x minus 13 is equal to 17n for some integer n. X minus 13 is a multiple of 17. Is it not? Okay. So if we put x is equal to 30, we can see that 30 minus 17 is 17, which is a multiple of 17. Therefore, the least value of x is 30. Okay. Now we got the value of x. Let us substitute here x. So write down this. In place of x, let's write 30. 7 into 30 minus 3 congruence p mod 17. That is 207 congruence p mod 17. That means 207 minus p is equal to 17n for some integer n. So 207 minus p is a multiple of 17. Okay, so do the division. 207 divided by 17, you get the remainder 3. Put p is equal to 3. We get 207 minus 3 is 204, which is a multiple of 17. So p is equal to 3 is the correct answer. Solve 5x congruence 4 mod 6. So here write down the sum. Write this 5x minus 4 is equal to 6n for some integer n. Okay, so 5x is equal to 6n plus 4 divided by 5. Okay, so here if you put different values of n, you will get different values of x. Let's find out these values. Put n is equal to 1. 6 into 1, 6 plus 4, that is 10. 10 upon 5 is 2. You get x is equal to 2. Now put n is equal to 2. You can see that 6 2s are 12. 12 plus 4 is 16. 16 is not divisible by 5. Similarly, n, 3, all this will not work out. So what you should do is, this first value which was correct is 1. After that, add 5. You get 6. Because here divisible by 5, no. So the for that reason, if I add 5, you get 6. Now check for n is equal to 6. 6 6 are 36. 36 plus 4 is 40. 40 divided by 5 is 8. See, you got the value of n easily without doing so many trials. Now don't try for 7, 8, all that. Directly 6 plus 5, which is 11. Try 11. Okay, 66. 6 into 11 is 66 plus 4 is 70, and 70 is divisible by 5. It will give us 14. So this is the. So similarly, you will get many more values of n and x. Just put dot dot. So the answer is x is equal to 2, 8, 14 dot dot. Okay, next sum. Solve 3x minus 2 is equal to 0 mod 11. So here the remainder is 0 itself. So here let's write down 3x minus 2 minus 0 is the same number, is equal to 11n for some integer n. Therefore 3x minus 2 is a multiple of 11. Okay, so here let's write down 3x is equal to, take the 2 on the other side, 11n plus 2, x is equal to 11n plus 2 upon 3. Okay, now here the divisible is 3, but let us first find out the first number. Put n is equal to 1. 1 into 11 is 11. 11 plus 2 is 13. It is not divisible by 3. Let's try with 2. N is equal to 2. 2 2s are 2 into 11 is 22. 22 plus 2 is 24. Divided by 3 is 8. So first number n is 2, not 1 for us in this sum. The next number, because it is divisible by 3, I'm not going to check for 3, 4. Directly I'm going to check for 5. 2 plus 3 is 5. So let us put 5. N is equal to 5. You will see that the answer is 19. X is 19. Again add 3. 8. Check for 8 only. So you get the value of x as 30. So forth. So the answer is x is equal to 8, 19, 30 dot dot.